Hi everyone, in previous class already we are discussed about the electromagnetic radiation behave as a particle in nature, and that is proven by two experiments like a black body radiation and the photoelectric effect. Thoroughly we can learn two effects like a black body radiation and the photoelectric effect. In today's class I wish to discuss the numericals based on their photoelectric effect. And see here, our first problem is calculate the energy of 1 mole of photon. Just remember this point, 1 mole of photon of radiation whose frequency is, they give us frequency, whose frequency is 5 into 10 raised to 14 hertz. So what they are asked and what they given to us, see here, calculate the energy of 1 mole of photon. They asked to us the energy is equals to question mark. What they asked to us? Calculate the energy. Energy is equals to question mark. We don't know about that energy. We have to calculate that energy here. And then whose frequency is? What they give us? Frequency means mu is equals to how much they are given to us? 5 into 10 raised to 14 hertz. Already you know that the equation E is equals to h mu. E is equals to h mu. This is a very famous equation for us. Then now we have to calculate the energy. E is equals to h means, already I told you in a previous class, h means the Planck's constant. Planck's constant. H means what? Planck's constant. The value of Planck's constant is 6.626 into 10 raised to minus 34 joules second. So this is the value of our Planck's constant. E is equals to h. H means the value is 6.626 into 10 raised to minus 34 joules second into, what is the mu? What is the frequency they give us? That is what? 5 into 10 raised to 14 hertz. So what will be the answer here? Sorry, this is our 34. So what will be the answer here? That is 33.13 into 10 raised to minus 34 and 10 raised to 14. So it is in the form of a raised to m into a raised to n, then a raised to m plus n. Minus 34 plus 14 is equals to 10 raised to minus 20. Then I wish to put, or I wish to shift this decimal point to a one digit, 3.313 into 10 raised to, then what happened here? This comes on the left side, then minus 1, that is the minus 19 joule. So this is the energy of one photon. This is the energy of one photon. What they asked to us? They asked 1 mole of photon, the energy of 1 mole of photon. But here we already find just only 1 photon energy. Then they ask 1 mole of photon. Already you know that in the first chapter, that is in the basic concept of a chemistry, I told you, just remember the 1 mole is equals to 6.022 into 10 raised to 23 per mole. So this number of photons into 1 energy of this photon. So 3.313 into 10 raised to minus 19 joule into 1 mole means 6.022 into 10 raised to 23 per mole. Then what happened? What will be the answer will come here? Just see, 3.13 into 6.022 is equals to 199.5 kilojoules per mole. So this is our answer. I hope you got how to solve this numerical very easily. In the numerical, there is very easy to solve this. What they are asked to us and what data they given to us. Just remember these two things. And next, remember some concepts like a mole, like a frequency, like a Planck's constant. So apply your knowledge and write the equation, fill the values in that equation, and you got easily the answer. And next question is, a 100-watt bulb emits monochromatic light of wavelength 400 nanometer. Calculate the number of photons emitted per second by the bulb. So what they are asked to us and what the data given to us here, the 100-watt bulb, the bulb capacity is 100 watt, and next, emits the monochromatic light of a wavelength. They given to us the wavelength means lambda. They give us a lambda is equals to 400 nanometer. And what they asked to us, calculate the number of photons emitted per second. They asked to us number of photons. Number of photons is equals to question mark. First, we have to calculate the energy of photon, the how much energy provided by one photon. The first step is to calculate the energy of photon here. So, energy of photon is equals to E is equals to h mu. Already you know that, but they don't give a frequency to us. They give a wavelength in the place of a frequency. But you know the formula of mu is equals to C by lambda. At the place of mu, can I replace the C by lambda? Yes, right. Then I wish to write here E is equals to h, mu means C by lambda. And already you know the value of h and C. So what is the h here? H is equals to Planck's constant, that is the 6.626 into 10 raised to minus 34 joules second. And what is the C here? C is the speed of light in the vacuum, 3 into 10 raised to 8 meter per second. And then fill the values here. H is equals to 6.626 into 10 raised to minus 34 into 3 into 10 raised to 8 meter per second divided by, what is the value? Lambda. So see here, they are given lambda 400 nanometer, but the SI unit meter only. So I write this value like this, 400 into nano means 10 raised to minus 9 meter. So I put this value here, 400 into 10 raised to minus 9 meter. So see here, h, c, lambda. Then what happens? 6.626 into 3 is how much? 19.878 into 10 raised to 34 into 10 raised to 8 divided by 400 into 10 raised to minus 9. The 10 raised to minus 9 will become the inverse here. Then what happened? 10 raised to 8 plus 10 raised to 9 is 10 raised to 17. Then 10 raised to minus 34, 10 raised to minus 34 into 10 raised to 17 is equals to again 10 raised to 17. Then 19.878 divided by 400 is equals to 0.0496 into what? 10 raised to 17. So I put this decimal point after the 2 digit at the right side, then 4.969 into 10 raised to minus 19. 10 raised to minus 19. 4.969 into 10 raised to minus 19. So this 19 joule. So this much of energy is provided by one photon. But they ask to us the power of bulb is 100 watt. 100 watt means the 100 joules per second. Then this much of energy provided by one photon, then this much of energy to 100 joules second, how much proton will provided to us. Then see here, that's why I write 100 divided by what? 4.969 into 10 raised to minus 19. Then what happened? What will be the answer we got here? 20.12 into 10 raised to 19. It got the inverse, minus 19 becomes 10 raised to plus 19. Then I wish to put this decimal point at the left side, 2.012 into 10 raised to 20. 10 raised to 20 per second. So this much of photon provided by 100 joule second energy. So this is our second problem. I hope you got the clearance about the solving method of these two numericals, and the next problem is